Right, so I'm going to talk about a topic which doesn't get enough attention in the world of data science, and I'm probably going to be a little controversial as well. So very quick introduction. So I'm currently head of data strategy and advanced analytics at Moneytomarket. I've actually been working with data and algorithms for over 20 years, so started in operational research, if anyone knows what that is, but it was, I guess, kind of data science of its day. So I've done stints at British Airways, Lloyds Banking Group. Before Moneytomarket, I was Insight Director for Club Card Strategy at dunnhumby. So quick bit about Moneytomarket. I'm sure most of you guys are familiar. We're actually the UK's most visited price comparison website group. So over the course of the year, something like 80% of all the online adults in the UK will visit one of our sites, Moneytomarket, Travel Supermarket, or Money Saving Expert. So that's actually more users than Facebook in the UK. And so basically we have over 1,000, well nearly 1,000 providers of products on our website, from anything from insurance, money products, car hire, and then they're all competing for business amongst the visitors to our site. So our mission really is to help our customers save money. So last year we saved UK consumers around £2 billion compared to what they would have otherwise paid. So it sounds kind of really great business, really easy business, helping customers save money, but it's actually really hard. So hands up here if you would like £1,000. Yeah, pretty much everyone. But actually getting people to visit our website and use our services is really tough. So that's where the data science and the machine learning come in. So one of the streams I look after is personalization. So we use our data to make sure we're always being as relevant as we possibly can. So as I said, we've got like 1,000 providers on our website. We don't want to just display random products to the customer. So this is an example of some of the simple stuff that works. So, you know, we create many hundreds of variants of one of our newsletters. This is a top 10 newsletter, and the ranking of the products in there is customized to groups of customers, and we get pretty decent revenue uplift as a result. And then sometimes what we do is more complicated. So we know that our customers have very different financial attitudes. Some people are very financially confident. You just need to show them, be very direct, show them rates, products, and that's what they want to see. Other people are financially anxious and cautious. So using the same language with all our customers doesn't work. So we've done a big project where we've uncovered the financial segments amongst our customers, and using natural language processing, we can actually tailor the content in our communications to those different segments. So here's just an example of a loans mailing aimed at two very different types of customer, but it's still the same product. So when you go to conferences and you read online, it seems really, really easy. Everyone talks about the great success they have, but actually there's plenty of evidence, plenty of survey evidence. Is an example here from Forrester, that actually companies are getting the return on investment on data science that they expect. So the question is, why is that? Well, I believe it's the mantra that's wrong. So if you keep hearing the same thing, keep reading the same thing, but actually the success rate of data science or the failure rate seems pretty high out there still, then it must mean that actually it's the messages that are wrong, and maybe we need to take a different approach. So one of the issues is that the C-suite, you know, they've heard about data, and they may well be very numerate, but being very numerate and being data savvy are not necessarily the same thing. So they've read somewhere in the Harvard Business Review that data is the new oil, so they need to collect lots of it. They need to hire people called data scientists with PhDs, and then somehow the combination of the two, some magic shit happens, and money flows. And money does flow, but it flows in the opposite direction, right? So hoarding data and collecting it isn't cheap. You guys aren't cheap, I hope. If you are, let me know afterwards. I've got some job vacancies. So that's not how it works, obviously. You know that. The other thing is a lot of companies think that somehow data is a magic sticking plaster over their problems. So they might have a really poor operations, really poor products, and they think data is a magic solution to fixing all that. But then there are problems within data science itself. So one is that there's probably too much self-importance for my liking. So, I mean, businesses are there to make money. So what happens if you're not on top of your cash flow, on top of your P&L, on top of your balance sheet? There's a big clue here. You go bust, right? You go bust. But what happens if your deep learning model is less than perfect? Probably not going to go bust. So we're going to go bust very, very slowly. So, you know, finance is really, really important if you want to stay in business and be successful. But we don't hear people going around with a similar sort of mantra saying businesses need to be accountancy driven. Everyone needs to be trained in amortization and depreciation, in the same way that we think that people should be trained in data science and data techniques in businesses. And essentially that's because data science needs to fit in with the rest of the organization, not the other way around, and we need to recognize that. One of the other problems is that people think that you just need to hire the right people, clever people, and they will magically get to work and automatically create some kind of value. But the problem is it's then left to people to figure out where the data is, to find it, to get access to it, to clean it, to do something useful with it. They're given no support whatsoever. And that's because a lot of organizations are still set up for the 20th century in terms of information architecture. So some of you may recognize this, but this is one of the real world problems that we used to have. So, you know, you've got a business problem. You need to find the data that's going to help you and figure out whether it's actually going to be useful. You have to request access via IT. Then you realize that, you know, the compute that you're given isn't big enough to actually process that data. Then you negotiate with IT, put an IT ticket in, say, can I have a bigger virtual machine, please? You wait for it to be provisioned. You install your languages and tools. You configure it for access and security. You do the scaling and the monitoring, and then you realize you can't access the machine. Then you forget a package that you really needed, so you have to go back and request it again. Then you get onto model building and so on. Right. So what happens is that a lot of data science ends up being stuck on local machines, and that's bad for two reasons. One is it leads to very bad development practices, and two, decreases the probability that will actually end up in front of an end consumer where it will be useful. Another challenge within data science is that unfortunately people focus too much on extreme accuracy, driven by things like Kaggle. So do you think it's better to do 100 things well or one thing perfectly?
One thing perfectly.
Okay, there's always one. Well, in business, it's typically better to do 100 things well. The reason is that you won't know up front, although you've done some work to figure out what has a probability of success. You won't know for sure what's going to work until you actually do it. So rather than invest a lot of time in making one thing perfect, you're better off trying 100 things and seeing what works. But the problem is, especially amongst junior data scientists, they're kind of like, there's too much focus on data science is machine learning. Machine learning is the accuracy on a test data set. There's actually a lot more to it than that. Another mistake is thinking that data science is a technology project. And again, this comes from old world thinking where you had to invest lots in, Oracle databases, SQL Server, Teradata, whatever technology before you could even access and use data. That's no longer true. You don't need to invest millions in an enterprise Hadoop cluster before you use data. What you should be doing is you should be using string and sellotape to produce any kind of results to justify further investment. Because technology projects, as I'm sure you know, have a very high probability of failure. They're extremely expensive, they're extremely slow, especially if they're waterfall projects. Another mantra which I don't necessarily agree with is, if you listen to vendors, listen to consultancies, they say data scientists should go out there, discover nuggets of insight that can drive the business and create value. And I'll just share an insight of my own. So when I was at dunnhumby, I remember Clive Humby said something which has stuck with me. He said, very early on, we realized that if we did insight for 10 million customers, we wouldn't get paid 10 times as much as if we did insight for 1 million customers. But if we sold 10 million coupons, we would get paid 10 times as much if we sold 1 million coupons. So basically, when I arrived at dunnhumby, I'll be honest, I was a little bit shocked at the level of analytics that was being undertaken. It was, let's say a little bit more primitive than Lloyd's, but still, dunnhumby was a massive money-making machine. So contrary to what people might think, it wasn't driven by insight for Tesco and other partners. It was driven by being able to monetize data on a massive scale for the very first time. I mean, over the couple of decades it's been in existence, they must have made, what, £1.5–2 billion in profit. And that's because insight does not scale. If you want to double the value from insight, you literally need to double the amount of effort. So, what I see there is a lot of waste. So, the problem with the current mantra is at least a lot of wasted time, a lot of talent is wasted, a lot of money is wasted. Naturally, when you see waste, I think of lean thinking, which came from Toyota's manufacturing system back in 60s, 70s. And it's been applied elsewhere since. Sorry about that. Oops. And then the other thing that springs to mind is Agile. So you'll have all seen the metaphor around scooter to car. But actually, if all you think is Agile is product iteration, you're kind of missing the point. It's mostly about close collaboration with the business to make sure you're working on the right things. So a couple of years ago, I read Russell Journey's excellent book, by the way, on Agile Data Science, and thought this is the way to go. But it didn't solve two problems for me. So the first one was, well, what do you work on to make sure that you're actually creating value? I mean, is it customer experience or some customer metric? But then there are lots of examples where you can improve customer experience and actually worsen financials. So if it's financials, which is what shareholders worry about, should you be doing an NPV or forecasting an NPV for every project you do before you start and using that to prioritize? So it's not necessarily straightforward to figure out what you should be doing. And then the other one was, it doesn't really solve the technology complexity problem. So, I'm quite handy at the Linux command line. Tim will tell you I create virtual machines for fun. But even for me, it took me a whole week to create an environment where I could follow all the examples in the book, which doesn't seem very agile to me. And we had exactly the same problem on our AWS data lake infrastructure. It was becoming really, really complicated to maintain. So I created so our CTO and architects, they couldn't understand why. So I thought, I'll put it in a language they can understand. So I created a architectural layer diagram. So basically, this is what you need for delivering data science. So there's lots of layers and tools. But that's not all. You need lots of resources to support that. And there's lots of vertical requirements around governance and security and so on. And when you look at this, you realize that actually this is really, really complicated to actually deliver and maintain. And this is probably more complicated to maintain than our website. And we had a fraction of the resource devoted to it. So about 18 months ago, we decided to change the way we worked. In true Agile fashion, we decided to try with the personalization workstream. So the first thing was to realize that data science does not operate in isolation of the rest of the organization. You really need to understand the rest of the organization's strengths, weaknesses, politics, your people, processes, and technology. So that led to looking at what we should work on. What is the organization really interested in? And the thing is, your business should already have a hypothesis for what generates value. It's called the company strategy, and the advantage should be that the company and the exec and everyone in the organization is aligned behind it. It's not obviously guaranteed. And that you should actively avoid working on anything else because, by definition, the organization has said, these are our priorities, this is our strategy, this is what we want to execute. Anything else shouldn't be as important. So when I do strategy planning, the model I like to use is SOSTAC. So it starts with situational awareness. That's broken down into objectives that you achieve through strategies, which are delivered through tactics, which are delivered again through actions. And the great thing is that this maps very neatly onto Agile Scrum methodology. So your objectives are your themes, your strategies are your initiatives, your tactics are epics, and your actions are stories, and those stories go on our Kanban board. And the other great thing is that not only do you get measurement on your actual stories themselves, but you've also got a slow loop back to your strategy, which is telling the organization whether your strategy is actually the right one or not. So what we do is we take that approach and we break down our work into very, very small batches. And this seemed like a really good slide a couple of weeks ago when I was putting this presentation together. Doesn't seem so great now, but the idea here is that we can keep our flow going. So because we've got lots of options and lots of stories on our board, it's almost impossible to synchronize with the rest of the organization, so especially downstream teams like marketing ops and CRM and so on. But if there's a bottleneck somewhere, we just pull another card forward. It means we're always working on something. And collaboration is the key. So because we're working on strategy, we've got senior buy-in from the CEO, the whole C-suite. We're structured around the data model, so both data engineering and myself reporting to the CDO. I have a dotted line into the marketing director who's responsible within the business for delivering personalization. We have shared priorities. We share bonus objectives. Who'd have thought that money was a great incentive for collaboration? I didn't until that. And then we needed to create a feedback loop. So without this, there's no science in data science. So you need to run pilots and tests. You build your models and segmentations on the back of that data. You embed. And this is really painful. This was incredibly painful because the teams we were working with were very much focused or had objectives set around outputs, not outcomes. So we were coming along and saying, right, okay, we're going to complicate your life because we want to run tests, we want to create test cells, we want more measurement. But we have kind of got through that pain, and now it's pretty routine. And we get feedback now on everything we're doing to understand whether it's working, and also create new data for further modeling. So I realized actually that when I did that layer diagram, I'd made a big mistake. I was thinking in the old world of layers of technology. What I should have been thinking was flow. So it starts with strategy, epics, stories that contribute to a data product. So we think in terms of data products. And what we should be focusing on is the flow between the source data and the data product, and having that feedback and iteration loop. So we also measure data cycles. So it's not just the outputs and outcomes that we measure, but we actually measure our data cycles themselves. How long does it take to create a modeling data set? How long does it take to score 10 million records and so on? And the idea is that we refactor and we iterate to get those data cycles down. So what kind of stumbled upon was what's called DataOps. It's quite a new area, and so it's not necessarily clearly defined, but this is where I kind of like to look at it, which is it's a combination of the best of data analytics with lean thinking, DevOps, and agile practice. So it's not been around long, so I guess it was first popularized by Andy Palmer in a blog, and this is Andy in his own words. So it's only been around since 2015, but it's not just a niche thing anymore. So it's actually got its own tracks this year at ODSE and Big Data London. So this is a little bit more detail. So it's really about agile collaboration to make sure you're working with the right people on the right things, data analytics, working at lightning speed, lean manufacturing, light focus on quality and control and measurement. But there are more steps to it, so we're only really scratching the surface. So question for you, why do cars have brakes?
To break.
To start going on.
Yeah.
Not to hit the barrier.
Okay.
Or people.
Not to crash into other cars.
Give you control. Slow the car down.
Okay, all good answers. There's another answer, which is so you can go faster. So when carbon fiber brakes were introduced on Formula One cars, lap times went down quite considerably. And the reason is that the drivers could go faster into corners because they knew they could slow down. Because even if we had no brakes, people would still drive cars. They'd just drive them at 5 miles an hour, so they could stop within a reasonable distance. But if they were really desperate, they could find a wall or a tree to slow down more quickly. So if we want to go faster using data, we also have to recognize that we need brakes, and that there has to be rules in place to be able to go quickly. So we have to build trust in the data. So the first set of trust is what I call for the what you do to data people. So these are data traditionalists. So this is all about making sure you manage access, privacy, the encryption, and so on. So this is there to show really the rest of organization IT primarily that you can be a data scientist and a responsible person at the same time. The other part of trust is making sure that what you do with data, so these are the users' data, trust that the data is actually accurate. So this is where all the testing comes in. So we're quite lucky we have a very good data engineering team that builds lots of testing in for it. One of the foundations of DataOps is actually reproducibility and version control. So it allows you to recreate your code at any point in time and allow things like rollback and allow other people to pick up your code and build on it. So obviously you'll probably be familiar with things like Git, and on top of that people have built services like GitHub and GitLab and Bitbucket and so on. But it's not just code reproducibility that is vital, but also your environment. So you need to make sure that your environment is reproducible. So that's your libraries, your packages, even your system level files, to be honest. So there's lots of ways of doing that. So there's things like Conda. You can use Docker containers, or we could even have an entire virtual machine. So version control also helps with speeding up your code, actually. So this is like a typical machine learning pipeline. But you can see that it can be split up into stages. And what that means is that people can work on different bits of that pipeline in parallel. But the challenge with that, obviously, is that if people leave it too late to do their development before they integrate their code, they cause problems for other people downstream. So in the DevOps community, they've developed the concept of continuous integration. And so this is something that you could also apply quite easily to data science. Which goes back to my point about you need to break down your work into small batches. But you can't just integrate any old code any old time. Obviously it has to be of high quality and it has to be tested. Now that poses problems for data science because the tests aren't quite as easy to implement as they would be for regular development. But you can still do it. So for instance, with the machine learning example, you could use the same test data set for your dev and master branch and only push into production if your model actually improved the AUC, or you didn't see too many observations flipping classification. And you can go further. So you have beyond continuous integration, continuous delivery, and continuous deployment. And modern data science platforms are making this easier to do for data scientists as well. So traditionally, we would have handed over a lot of our work to our data engineering team. They would have recoded it, refactored it, scheduled it for us. But with modern data science platforms, you have the ability to do a lot of this yourself. So once your code passes tests, it can be pushed to an API, it can be scheduled by you and so on. And you also need continuous operations. If you have your website, which is calling one of our modeling APIs, the last thing you want is for that API not to be able to handle the traffic and slow the load pages down. For us to then need to raise a ticket to IT to create a bigger machine or something. So you need the right tools to do all this, obviously. But just like chemistry is not about the tubes, DataOps is not about languages, it's not about a particular vendor or package. But the right tools do help. But when I'm picking tools, I never start with the technology itself. Too many people get too excited by technology. The thing to realize is it's just going to be obsolete within 12 months. So when you're deciding what tools to use, I like to use this, which is the SPY model by Treadway, Rue, and Perold. So in order to understand what tools you want to use, you need to know what practices you want to employ. To understand what practices, you need to understand your principles, your values, and what needs you're trying to fulfill. So for us, the need we're trying to fulfill is to help our customers save money, and being able to quick to respond to our customers is very important. So one of our values is speed. We also talked about security and quality. We want to apply agile principles, lean thinking, and so on. So that kind of tells us what kind of tools are going to be useful. But before I get onto that, a bit of advice, which is you should really try and avoid building your own anything. This is one of the pitfalls we've fallen into, because anything that's useful will eventually get commoditized and provided as a service. So you want to let someone else be the beta tester and iron out all the issues. And the other thing is, obviously technology ends up in a cul-de-sac as well. But the other issue is that cost of delay is probably the biggest unmeasured cost in business, and it can be actually massive, right? So while it may seem cheaper on paper to build your own solution, the problem is while you're waiting to develop that solution, you're actually just handing time to your competitors by not actually doing something right now today. So one of the things we kind of realize is it's a bit of a false economy doing that, and obviously things always take twice as long to develop in-house anyway, even after you've already factored in that it's going to take you twice as long as you think. So what we want tools that cut out all this, and that means not relying on other teams to provide that infrastructure and that package management for us. We want that self-service capability. And thankfully, data science platforms are coming along, which help with this. So they enable the data scientists to self-serve the infrastructure to pick, the size of instances they want, what libraries and packages they want installed. They automate a lot of the collaboration and version control for you by automatically checking in your code, and also helping you deploy. So one-click deploy to our shiny dashboards, to APIs, and scoring servers, and via Docker containers. And also scheduling as well. That's a major benefit for us. Lots of people have recognized that this is a massive market, so these are just some of the vendors out there. Like I said, which one is right for you is very much going to depend on what your needs are. But there's also another advantage of the DataOps approach and the self-service approach. Seem to have missed a slide somewhere. Yeah. Sorry, skipped over that one. The other big change in the market over the last couple of years has been the shift in cloud computing, which was originally just infrastructure as a service, then became platform as a service, then software as a service, and now serverless. So what that means is it allows you to not worry about scaling, orchestration, installation of anything. You just bring your code and your data, and you're ready to work with it. So this is Google's reference architecture for big data. And we were so impressed by this that we're actually shifting our data analytics out of AWS onto this. And it's a really great platform to use. And the other advantage is it gives us a single unified platform for analytics and reduces our requirement on other teams, so everyone can access anything in this environment. So So one of the other big advantages for us is it reduces the dependency on other teams. So with the DataOps approach and self-service, you don't need to worry about DevOps, infrastructure, sysadmins or DBAs. The users of the data are really in the driving seat, and they can self-serve their own needs. And that allows for much greater collaboration, far fewer bottlenecks in the entire process. So I'm just going to summarize now. So what you need to be looking for is, when I think of AI, I think of actual intelligence. So you want to look for opportunities where you can action your data directly to the end consumer of that product. Which means that we have a focus on what we call data products rather than projects. So a data product could be a machine learning model, could be a segmentation, could even be a dashboard, could be a modeling data set. But they all have owners, and those owners are responsible for maintaining them, refactoring and improving. You want to find the fastest, cheapest, quickest way of getting your data in front of the consumer. So we actually prioritize work that fits in our data ops workflow over other projects. And you want to optimize, this is obviously Jeremy, so it's speed. So that's really our big focus. We know that the faster we can respond to customers, the bigger the benefit we have. And you need to build trust in data. And this is probably one of the hardest parts and the least fun part of my job, to be honest, but it has to be done. But it mustn't be an overhead, and it mustn't be a barrier. You just have to accept that it's there to help you. So you need to invest in the actual process itself so it doesn't become an overhead. So hopefully we can move to a world where data science today is a lot of hamster wheel analytics, a lot of people doing a lot of work locally, putting in a lot of effort that never actually goes anywhere. People who manage to get something done once but then can't reproduce it, a lot of aimless, let's just see what the data is telling us. Roadblocks caused by all kinds of things. People who can actually action their data science, but then there's no measurement of the effect it's actually had. To what I call the data science factory, which is agile collaboration, make sure you're working on the right things with the right people in the business to create data products, that you have the right governance and processes in place to get the data to data products as quickly as you can, and that you're measuring value and that you can iterate as rapidly as you possibly can.